Good day and welcome to Electric Drives and Control, MEE 433. So this is your instructor, Sir Gabs. So this educational video is made especially for the mechatronics engineering students of Bulacan State University. So this will be the first video on our subject. So pagpasensyahan nyo na ako medyo hindi maganda yung ating audio. Simula pa lang naman to. And this particular video will focus on the introduction of electrically controlled systems, particularly on electric drives. So first and foremost, gusto ko lang i-congrats yung mga nanonood nito. Definitely, dahil nakarating kayo dito sa subject natin. So if we go back to our previous subjects, like yung Enercon, we already discussed the working principle of an electric motor. So in this particular subject, you can expect that we are more focused on how to control an electric motor, hindi lang kung paano siya umikot. So especially yung mga three-phase AC motors. So let's get started. So first of all, we have to define what is an electrically controlled system. So an electrically controlled system is a physical interconnection of devices that influences the behavior of other devices or systems through electrical means. Ibig sabihin, as long as merong interconnection, iba't ibang klaseng devices, influences a behavior. So particularly, nakokontrol niya sa pamamagitan ng electricity. Okay? So, an electric drive, of course, is a kind of electrically controlled system. So, an electric drive, as we can define, is a form of machine equipment designed to convert electrical energy to mechanical energy and provide electrical control of the process. So, ang focus ng electric drive is the conversion of electrical energy to mechanical energy. Okay? So we can say that an electrically controlled system comprises of one to several electric drives. Pwedeng ganon. That are interconnected to each other. So, mga examples ng electrically controlled systems that utilizes an electric drives include circulation pumps, compressors, yan, familiar tayo sa pneumatics niyan, manufacturing systems, refrigeration plant, and of course, motor control panels. Sa ating subject, we will be mostly focusing on motor control panels. Okay? So, in the topics that will be discussed in the course of our subject, electric drives and control, one of the lessons objective is for the students to have learned to control an electric drive. So, electric drive, an example, is a motor. So, we want the motor to perform tasks that kung paano natin siya gustong gumana. So, how we want it, where we want it, kung saan natin gustong gamitin, and kung kailan man natin siya gamitin. Okay? So, what are the primary reasons? Bakit ba tayo gumagamit ng electric motor? So, marami yan. So, first of all is to actuate an object. So, if we actuate an object, ang isang halimbawa niyan is to move a conveyor. So, we move an object linearly gamit yung isang conveyor. Okay? Or simply, utilizing the rotational movement, kakabitan natin ng LC, tapos magagamit na natin siya pang cooling. Okay? So, given the definition of electrically controlled system or an electric drive, we can say that yung mga motor natin na kino-control, hindi siya nag-iisip mag-isa. They are not thinking machines. They are not self-aware and they cannot make their own decisions. Okay? So, that is why we have to create a control system that can perform kung paano natin siya gusto gumana. So, i-discuss natin later kung paano. So we can say that an electric system in its direct form is used to perform sensory or logical functions in automation. So data is sent, processed, received, and stored in electrical signals. So more on that later. At the most basic level, electrically controlled systems are used in starting and stopping an actuator. So, familiar naman tayo sa mga actuators, but first we have to define an actuator. So, actuators are devices that takes one form of energy and converts it into mechanical movement. So, ano ba yung mga form of energy na yan? As an example, electric, hydraulic, and pneumatics are three different forms of energy. And this energy that will be converted into a mechanical movement, yung mga mechanical movement na yan is the linear and rotational movement. Okay? An example of an actuator that converts electrical energy to linear mechanical movement is a solenoid valve. So, isa namang example of an actuator that converts electrical energy to rotational mechanical movement is an electric motor. An example of an actuator that converts pneumatic energy to linear mechanical movement is a pneumatic cylinder. And an example of an actuator that converts hydraulic energy to linear mechanical movement is an hydraulic cylinder. So for rotational movement of both pneumatic and hydraulic energy, cylinders can be mechanically modified to produce rotational movements. Also, pneumatics and hydraulic motors are also available. Okay, so aside from starting and stopping actuators, electrically controlled system can also influence actuators in several ways. So mga examples nito is aside from start and stop is the change in direction. So for example is a motor, we can change its direction, pwedeng forward, pwedeng reverse. Modify actuation force and speed. So using an electrically controlled system can also adjust speed. So sa pneumatics meron tayong ginagawa para mabilis yung pag-extend or retract, pwede yun. So we can also time. So for example, we can set time on when an actuator will move. We can also count how many times an actuator move. Sequence, like dun sa pneumatics na A plus, B plus, A minus, B minus, so on and so forth. Compare, so we can also compare. For example, if there are two motors working simultaneously, so merong probably sensors that can detect that they are working simultaneously, thus can perform another task. Compute and communicate. So yan yung mga nagagawa ng electrically controlled system to influence actuators. So on a basic level, electrically controlled system can be divided into three parts. So number one is inputs, which can be identified as the switches and sensors. Switches and sensors can be viewed as the inputs of an electrically controlled system. So, as an analogy, these are the eyes and ears of an electrically controlled system. Next is the outputs. So, the outputs are the hands and feet of the electrically controlled system. The output devices will respond based on the request of an electrically controlled system. Based naman siya dun sa mga inputs natin na nadedetect or signals na nadedetect using switches and sensors. So, for instance, magnetic contactors can be considered as an output that controls a motor. In hydraulics and pneumatics, solenoid valves as an output can control cylinders. The next is the internal part of the unelectrically controlled system. So program instructions or hardware logic are the brains of an electrically controlled system. If this is wired incorrectly to the inputs and outputs, the system will not function as intended. So simply because when a system is disconnected to the output devices, the actuator won't start. Okay, so if they are not interconnected properly, there will be a malfunction in an electrically controlled system. So one of the most fundamental characteristics of an electrically controlled system is the differentiation of the control signals and what is being controlled. Okay, so nahati yung ating electrically controlled system sa dalawang parts. First is the control/pilot circuit. Ito, so which is influenced by low voltage, low current, and low power. So control circuits usually has low voltage, low current, low power signals that is entirely separate and electrically isolated from what is controlled, whether it is hydraulic, pneumatic, or higher voltages. So the control circuit is in charge of signaling the power circuit to take an action. So ito naman yung isang example ng isang control circuit. So merong low voltage na 24 volts DC and push buttons and then a solenoid valve. An example naman for a power/primary circuit, which are as defined earlier, hydraulic, pneumatic, electric. So the electric can be defined that high voltage, high current, and high power. Kaya pwede natin sabihin na power circuit kasi high power. Okay? So an example of that is this. A hydraulic circuit, simple circuit of a 3-2-way directional control valve with a single acting cylinder. Okay. So the control circuit again is in charge of signaling the power circuit to take action. So the power circuit responds to the request of control circuit. Ang dapat natin laging tandaan dito is that they are very electrically isolated. Okay? Papansin natin sa labas lang natin yung laser pointer. Yan. Pansin natin dito, we don't have any electrical connection. So yung 24 volts natin that we used, dito lang siya sa control circuit. And this one, sa power primary circuit, it is powered by a pneumatic or hydraulic energy, okay, through this pump. Okay, so discuss lang natin konti. When push button 1 on the control circuit is pushed, the solenoid will be energized, of course, and thus movement of a 3-2-way directional control valve will occur on the power circuit, and thus the cylinder will completely extend. So this is very familiar sa inyo kasi napag-aralan nyo na yung pneumatics and hydraulics. So the question will remain that how can this pneumatic circuit or hydraulic circuit differ if an electric motor is to be controlled? Okay, so yung papakita natin sa susunod. Okay, so consider a 3-phase AC motor, okay, with a high voltage rating of 440 volts, which is controlled by a PLC or a programmable logic controller. Okay, so the moment na pindot natin to, may mangyayari dyan. Okay, so at its de-energized state, the contactor is in its normal non-operating condition kasi nga hindi pa naman pipindutin to. Okay, At any rate na pinindot natin yan, but when the normally open push button is pressed, a low voltage signal will be received by the PLC. Okay. Then, if the PLC is programmed correctly, the PLC will give a signal to the magnetic contactor. Okay. Magnetic contactor coil. Usually, yung nasa control/pilot circuit natin na may kinalaman sa relays and magnetic contactors, it is usually the coil only. So, the magnetic contactor contact will be connected, thus will provide a 3-phase high voltage supply dun papunta sa ating electric 3-phase AC electric motor, and the motor of course will then run. Okay. So what can be the reason why there's an isolation between the control and power circuit? At this case, sa case na to, makikita natin yung control circuit natin 24 volts. Ating power/primary circuit is 440 volts 3-phase. So they are very different. Okay? So isolated lang siya using a magnetic contactor coil and its contacts. Okay. So what can be the reason? Bakit kailangan ng isolation? So of course, one of the primary reasons is safety. In a power circuit that utilizes higher voltage, higher current, and higher power, of course, there is a chance na, of course, mas delikado yun. Okay? So, the voltages that is used in a control/pilot circuit is usually 220 volts AC, 110 volts AC, both single phase. Sometimes, very rarely, meron 24 volts VAC single phase. Tapos 24 volts VDC employed by most control circuits. So ito yung kadalasan ginagamit sa field. So 24 volts DC. So why do we use such small voltage? Of course, number one, nabanggit natin kanina, is the safety. Next is yung ease, madali lang siya kasing gamitin. And next is the isolation. Okay? When we try to troubleshoot an electrically controlled system, especially mga motor circuits natin, most of the time yung i-check natin dyan kapag may malfunction is the control or pilot circuit. So yung control/pilot circuit natin, so mas mahirap yan i-maintain kung high power yan. So mas madali siyang ayusin, gawin, mag-perform ng maintenance at low voltages. Especially 24 volts DC. Yung power and primary circuit naman natin, of course, employs high voltage, high current, and high power. So usually 3-phase siya. Might be 208 volts AC, 220 volts AC, 440. Minsan meron pang 560. Okay, so, and of course, high pressure hydraulic. And pneumatic din naman. So, yun yung ating power circuit. So, just think of it, kung sakaling we have 3-phase 440 volts AC and suddenly, kinabit natin siya dun sa pilot circuit natin or sa control circuit natin. Of course, hindi magiging maganda yun kasi yung mga loads natin sa control/pilot circuit is only low voltages. So, if we insist na kabitan siya ng high voltages, wala tayong isolation doon, so I think there will be a problem, especially sa ating safety. So additional information for single phase versus 3-phase. Sa field kasi minsan may maririnig tayo mga technicians magsasabi ng 2-phase. So, there's no such thing as 2-phase. Walang 2-phase. 2-phase might pertain to single phase. So, in single phase, meron tayong line 1 and line 2. So, ito yung usually na ginagamit natin sa bahay. Using the line 1 and line 2, we can have an AC waveform na iisa lang. Okay? In 3-phase, L1 and L2 can produce 3 sine wave combination siya ng L1, L2. Pwedeng yun yung isang kulay, yung L2, L3, yung red, L1 and L3. If ever ibaliktad man natin yung L1 at L2, it can produce the same sine wave. Okay, so let's see a schematic diagram. Okay, so ito ay makonsider natin as a schematic diagram, and we use schematic diagrams to draw the control circuit, only the control circuit of an electrically controlled system. However, in actual practices, this may be difficult. That is why an alternative control circuit is shown using a ladder logic diagram. In our subject, we will focus on using the ladder logic diagram. Kasi if we use schematic diagrams, it can be more complicated. For example, in this case, meron tayong isang solenoid valve. What if dumami yung load natin, dumami rin yung ating contacts using the same power supply. So the schematic diagram will be hard to read, will be very difficult to understand, unlike sa ladder logic diagram that we can add components easily. Okay, of course the power circuit that we used earlier will not change. Yung pag-change lang naman natin ng schematics to ladder is applicable only to the control circuit. Another example is a three-phase, yung kanina. So three-phase AC motor with a magnetic contactor. So we have a schematic diagram of its control circuit. So if we convert it to a ladder diagram, so ganito yung magiging itsura. Okay, so we have a switch, a load, that is magnetic contactor, okay, and a 24 volt DC supply, and a ground. Using ladder logic diagrams, we have several do's and don'ts. Okay, in a ladder logic, the high side, so ito yung 24 volts DC, is the left vertical upright line. This is called the high side. So the low side is in the right, labeled with ground or 0 volts. Okay, so input devices are always on the left. So input, mga halimbawa niyan is switches, sensors, always on the left. Loads are always on the right. Okay, so for this example in the right, which is baliktad, yung load natin nasa left, yung switches nasa right, so that should not be done, so it's a don't. Okay, okay, so loads are always on the right. So meron siyang exception, yung tinatawag nating overload relay contact. We will discuss that in the future lecture kung bakit siya exemption. Okay, but for now, so ito muna yung susundin natin. Loads that are found in the control circuit are usually coils of a relay or a magnetic contactor, hindi yung kanilang contacts. Okay, so there's also a rule that is called one load per line or per rung. In a ladder logic, loads cannot be connected in series. So as much as possible, per line, isang load lang. Okay, so we have to discuss AND logic. Okay, so AND logic can be done if we use two different switches and put it in series. So gumagana lang siya kapag pinindot yung parehas na S1 and S2. An example of a practical application for AND logic is when, for example, an operator needs to run a motor, but there's a condition na kailangan hawak niyo yung parehas na switches to prevent an accident. So, ang logic will be very useful. Okay? Next is the OR logic. So, we can do OR logics also sa ating mga electrically controlled system, especially electric drives and control, by putting S1 and S2, the two switches, in parallel. So, we can also use more switches if needed. Okay? So, this one will function if S1 is pressed, the magnetic contactor will be energized. If S2 is pressed, the magnetic contactor will also be energized. So this is useful for applications na kailangan nyo ng bypass control. Okay? Okay. So in a slightly more complicated circuit, nakita natin dito, utilization of a relay to control various power circuit components simultaneously can also be done. For example, in this case, S1 and S2 and R1 is in series. So, by pressing S1 and S2 simultaneously, okay, so R1 coil will be energized. And then if the R1 coil is energized, the R1 normally open contacts connected to the magnetic coils will change state. Magiging closed contact na sila. And the magnetic contactors 1 and 2 will also function. Okay? Since nag-function na yung MC1 and MC2, their open contacts will be closed. Okay? So, by changing its state, the coils of MC1 and MC2, dahil energized na sila, will result to the closing of this contacts, MC1 and MC2. Thus, ang mangyayari dyan, the three-phase voltage supply will flow through lines 1, 2, and 3. Lines 1, 2, and 3, and will result to the motor running, both of them. Okay. Ayan, so before we end this video, I want to show you implications of putting improper wires sa ating circuit. So for example, if we connect a wire here papunta dito below S2, mangyayari dyan, kahit pinutin na lang natin yung S1, R1 will be energized and the whole circuit will function. Okay. So what if dun sa contact na R1, sa second contact niya, we also put a jumper wire here. So mangyayari MC2 natin will be always energized. Thus even pinutin natin yung S1 or S2, it will not affect the MC2 kasi directly connected na siya sa 24 volts. So in these scenarios, we can say that it is really critical to check the connections between different switches, contacts, and the like. Kasi if we made a wrong connection, the purpose of our circuit, kung ano man yung gusto nating ipagawa sa kanya, will not be done properly. Okay? Usually, nangyayari ito sa mga processes, nagkakaroon ng bypass. So, pag nagkaroon ng bypass, tulad nitong wire na to, jumper wire na to, hindi masusunod yun, mababaliwala yung S2. So, imbis na yung safety sana ng operator ay ma-check or ma-maintain, hindi ma-maintain because kahit isang push button lang pindutin natin, gagana na siya. Okay? So yun. Okay, so that concludes the introduction to electric drives and control. Okay, so the next video will tackle about the circuit breakers, magnetic contactors, overload thermal relays, para mapag-aralan pa natin yung mga parts or yung usual parts na ginagamit natin to create an electric drive. So, see you sa ating next video. So, hopefully natuto kayo. If you need to watch this video over and over again, please do so para maintindihan ninyo. If there are questions, you can always contact me dun sa ating Edmodo. Okay? So, that's it. Thank you very much for listening. I hope natuto kayo and see you sa ating next video.